Anyway, welcome to the next session that we have today. Session 2B is on 3D and SIM in planning. There's going to be some really exciting presentations here. Looking forward to seeing them. You know, so much of our discussion is around 3D models with transportation and visualization. But, you know, the 3D is really critical for supporting communication and outreach as well. You know, project teams, construction, stakeholders, all kinds of people really benefit from this sort of technology. So we're going to have 3 very good presentations that focus around this sort of approach. And up first, what I'm going to do is just introduce them and let them tell you pertinent information about themselves. But up first, we have Leilei Duan. She's from the University of Florida, and she's going to be presenting 3D parametric modeling to understand the future growth of our cities.
Hi everyone, thank you for attending this afternoon session. My name is Leilei Duan. A little bit background about me. I am currently in my 3rd year PhD program in University of Florida, majoring in urban and regional planning with a focus on geodesign. And the topic I'm presenting today is using 3D parametric modeling to understand the future growth of cities, and especially focusing on the 3D infill allocation in the city of Tampa. Urban sprawl has become an issue for most of U.S. cities. If without the better planning approach, it is going to be a continuous problem for us. And there are many damages, known damages are done by urban sprawl. For example, like obesity, loss of wildlife habitat, water overconsumption, air pollution, traffic congestion, so forth and so on. And under these circumstances, many people are finding paths to get more decision support tools and methods established to help public to get more involved in the decision making process. And recently, a new member joined the big family. It's called geodesign. How many of you have heard the word geodesign? All right, not many. So a little bit background about geodesign. Geodesign is a new terminology. Actually, it's not a new concept. There are many definitions, but I picked out 2, one by Bill Miller, one by Michael Flaxman, which are the most acknowledged ones and my personal favorite too. So Bill Miller's definition is the purpose of geodesign is to facilitate life in geographic space. And Flaxman's definition is it is a design and planning method which tightly couples the creation of design proposals with impact simulations informed by geographic context. And there are a couple of frameworks of geodesign. The most known one is Steiner's geodesign framework and the Miller's geodesign framework. I circled out the most important part. For planners, you can tell that what they have in common is that they emphasize on the feedback loop in the planning process. So they're focusing on the planning is not just one way. It's not planner says something and you do it. They are more focusing on the impact of that decision and then go back and change different scenarios and change your variables and then do multiple scenario planning and to evaluate your model. So that's one big part that geodesign is focusing on. This is the overall workflow of this study. The workflow is it's a little bit hard to look at the yellow color. I'll read it out. So the workflow is focusing on the first one is quality of life analysis and land use suitability analysis. That's the first step. And then we are going to use these analysis results to look at the second one, which is population and employment allocation. And then the third one is talking about different scenarios that we're going to do. And the final part is the impact on environment, transportation, local economy, and so forth and so on. This is totally a geodesign process because we are going to use the impact analysis to inform the scenario that you're going to use, and then use the scenario results to look at whether the quality of life has been improved or not. So that's like a total overall of the workflow. A little bit background. So for the land use analysis part, we're going to use something called land use conflict identification strategy, which is basically a goal and objectives-driven land use suitability modeling process. So, for example, if you want to look at how the land use suitability is for single-family residential, you will have your sub-objectives and you will have the land use suitability modeling for each one of those, and then give them a different weight, and then to have your final land use suitability results for the single family residential. And we're going to do that for every type of land use. And previous presenters have mentioned City Engine. I'm going to talk a little bit more about it because this is a software that mostly used in this process. So City Engine is a software that is a massive modeling software, and the reason that we use it is because it's rule-based and is tightly related to ArcGIS dataset. So it's quite there's no gap while you transfer data from ArcGIS to City Engine. And it's data-driven design. So once you change the data, it's really easy to just change your design scenarios. It can build flexible scenarios faster and create realistic context and to share the urban plan. And the GIF that moving there is like, it's a website, it's a web scene, so it shows you how the results can be. It's just shows a link in the browser. You can share it with your client, with public. And the benefit of City Engine is, if you look at the graphic on the right-hand corner, if you use a handcrafted, the time that you're going to use to model like a city model or something is going to be a lot of time. But if you use procedural modeling, it takes a little bit more time at first to write the rules. But then once you write the rules, and all you need to do is to apply the rule to your data to generate the models. And I used this screenshot from the City Engine help file because I don't have access to the newest version yet. It just came out last month. So this is a user interface of the newest version for those of you who are not familiar with the user interface. So City Engine, if you look at the number 4, which is the middle, they actually have the scenario planning benefit to it. So you can have different planning scenarios side by side, and you can change data and design variables in each one of them to show the comparison. And the window number 2 are the CGA code. CGA stands for Computer Generated Architecture, and that's a core to the City Engine process. And you write your rule entirely in that window, and then you apply it to your data. And then if you look at the window on your right-hand panel, and those are the variables, and you can change, just quickly regenerate your scenarios. So the methodology that I used in this process, basically we divided Tampa's development type into 3 types: infill, greenfield, and redevelopment. And for the development type we're going to look at, there are trend, there are future land use, and design driven. And the final goal of this research is to mix match all of those scenarios together. And the one I'm going to discuss today is just a tiny part of it. It's just show you example of how it works, which is to take the infill sites and then look at trend. And the trend in this context is the trend of the volumetric trend. So in other words, if your infill site is located surrounded with all skyscrapers, and we are going to assume that your new buildings here are going to be very similar volumetrically to the buildings surrounding. So we are going to simulate that building volumes to it, and then to estimate how many employment and residents you can put into that building to inform the allocation results. So this is the land use suitability results based on the LUCIS process that we talked about. This shows a mixed use opportunity. So the mixed use opportunity is combined with commercial preferences, multifamily preferences, and retail preferences. So that's what we consider as mixed use, or commercial, multifamily, and retail. And in the right-hand map, you can see that it's red to green. So green is the most suitable area for mixed use opportunity, and the red ones are the most not suitable area. So when we look closer to those green area in the mixed use opportunities, there are a lot of those parcels, but not every parcel is suitable for development just because of parcel nature. Sometimes they're just too small. They're a very small piece of something, or they are of very weird shapes. So we have further regulations to exclude out those parcels. All right, those colors are not showing up again, so I'll read it. So to generate the 3D buildings, we have 4 big parts. We have to know which are the buildable lots, and which are the footprint area, what is the building height, and what is the building typology. So these 4 things are the ones that we looked at. As far as those branches up there, those are the regulations to restrict each one of those elements. So the buildable lots, footprint area, and building typologies, we gave user flexibilities to choose those things. In other words, once you pass this methodology to the client can say, well, I want certain area, minimum area as my buildable lot. They can define their own minimum area, or they can define their own setbacks to create a building footprint. Or they can say whether I want a U-shape, whether I want an L-shaped building, or just a parameter block. The only thing that it cannot change is the building height, because in this trend scenario, we already talked about the definition of the trend. The trend is to look at the surrounding existing conditions to generate buildings in this infill site. In other words, we are going to look at the surrounding parcels, floor area ratio and total living area, and to use those to estimate how many total living areas are going to be in your infill site, and use that, and based on how big your building footprint are and the shape of your building, to generate the building height automatically. And these 12 criteria are the ones we use to select the buildable lots. Basically, they are divided into 2 categories, the geometric and the functionals. I'm not going to details, but these ones are, the users can have flexibility to change the threshold they put into each one of them to choose a suitable site for infill. And after that, initially we have more than 7,000 vacant parcels in Tampa. And after dissolve the vacant parcels that are adjacent to each other to merge them into bigger buildable lots, there are more than 4,000 of them. But after applying the 12 variables, there are 436 that are left. And this part is showing you how the users can have flexibilities of creating the footprint by setting the setbacks in CityEngine themselves. This one is showing two different types of setbacks creation. The first part is to use a scale. In other words, the user can say, I want the building footprint to be 80% or 70% of the entire lot or something. So they can change that, and the footprint will shrink from the edge of the lot. And the second method is they can define what the front setback, back setback, and side setbacks are to create the building footprint themselves. And this one shows how the building height is generated. The building height is generated based on the GIS data. So how many parcels around you are, for example, condo and commercial and retail, and based on their total living area and their FAR, and the building height will be automatically calculated through CityEngine ArcGIS to generate the mixed-use building height. And these variables here are just showing the number that are computed in CityEngine. Those numbers are not user controllable. And this portion is how the CityEngine is doing the allocation. So the user have control of saying how many area per employment. So for example, in this one, we are putting 500 square feet for each retail employment and 300 square feet for each commercial employment. And based on how many square feet of retail space and how many square feet of commercial space you have in that building, CityEngine can automatically report how many commercial employees and retail employees that you can allocate in this new building that you put there. And this is like a result of what those infill sites look like if we all put mixed-use buildings in it. These two images are exactly the same. I just color them differently to show you which sites are the infill sites. And in these, the color means, the yellow means condos, and blue means commercial, and red means retail. And those color ones on the right hand are the existing commercial and retail ones. So this is not the complete for the whole over workflow that I just showed. It's just part of it. So the future research will be on the dashboard. We will have a dashboard reporting the allocation results. So for example, how many retail employment are actually allocating to the city based on the building typology. And future land use allocation scenario, we were just talking about based on the trend, based on what's surrounding you, but each city have their own future land use regulation already. So we are going to look at that. How many allocations can you done based on that scenario? So compare with the trend. And the same goes with the design-driven allocation scenario. This one will be driven by urban design guidelines. So for example, urban design guidelines can say you will have to have some certain percentage of storefront at the first floor or something. And if we, based on that, and build the buildings to see how many people you can actually allocate there. And of course, we were talking about for geodesign process, you have to have the impact analysis and model evaluation. And that's where we will going to look at the quality of life index evaluation to look at whether after allocation or after the scenarios that we came up with, whether the people's quality of life has been improved based on our allocation. That's the future research, and that's it. Thank you.
Any questions?
Yes.
Did you get the data for existing buildings in terms of heights and square feet for retail, number of condos? Like, was it readily available in GIS format?
It is yes, it's in the parcel data. We actually did a little bit calculation because we basically are. So in GIS parcel data, they have the total living area, the heated area, and they have the building footprint. So we just divided that to get a number of floors.
But how do you know percent of retail, percent of commercial in each building?
Oh, those existing buildings are just like, they just single use. So
okay.
Yeah, so those like color ones are just single use.
I got a question.
Yes.
So this information you generate, that feeds into planning recommendations of how tall buildings become, how much should be commercial, residential, retail?
Yes. This one is just a trend analysis. So it's just based on the existing conditions. If you have nothing other regulations going on, the buildings are going to look like this. So trend analysis usually will be like a comparison analysis based on other, because you will have other scenarios, like you will have more design-driven, those scenarios, but they have something to compare with, and the trend analysis is serving that way.
Have planners used this particular technique on current planning situations to develop exact types of buildings, or just approximate types of buildings? Has it been used in the real application yet?
I hope so, because this is my dissertation.
Okay, but this is still in the beta area, it's not in the full.
No, yes, this is beta. Yes.
I have a question.
Yes.
Sort of technical question on simulation.
Yeah.
With the rules specifically, and
Right.
that can be a challenge.
Yeah.
And they certainly deny that. But did you find that you kind of created a library and then you were able to use that, for other applications and continue to build off of that? Or did you kind of establish your own set of rules, or did you
Yes.
tell me a little bit about that?
So probably not in this one specifically, because this one's rule is actually quite simple, because you can see there's no facade applied to it. But I do have like, based on, for example, I do have library, how do you generate buildings automatically based on FAR?
Great.
And those kind of thing. And then I'm trying to build others like facade related libraries as well. So
Just a new, I think the newer version has
Mhm.
where you can pick a city,
yes,
a style. Did you see that?
Yes.
The style of the city and
Yeah.
people running the buildings that
That's
way.
true.
So that's very interesting.
Yeah.
Just to try that.
yeah. But I think most cities they pick is like New York,
Yeah.
those kind of thing, less Tampa-ish, Florida-ish
Yes,
style.
very true. Any other questions?